Crisscross rule, Module 2, Lesson 9. Ionic compounds. Ionic compounds are called formula units. Today, we will look at an easy way to create ionic compounds using the crisscross rule. To do this, we need to know the common ion or charge of an element when it gains or loses the valence electrons. You can figure this out by using the periodic table and looking at the column the element is in, or using the common ion table in your resource package, you are able to find this information. A formula unit is a ratio of the positive metal to negative nonmetal in an ionic compound, which is called a crystal lattice. Formula unit. To further explain the ratio of the formula unit, let's take a look at two different sized salt crystals. So in this first crystal, if we were to count the number of chlorines, we would see here that we have 1, 2, 3, 4, 5, 6, 7, 8 chlorines to 1, 2, 3, 4, 5, 6, 7, 8 sodiums. Now that's on the front face. Now if you look at this lattice, there's actually 1, 2, 3, 4 rows of the NaCl pattern. So in this image, there are a total of 8 times 4, which is 32 chlorines, and also 32 sodiums. Now this ratio of 32 to 32 is just a ratio of 1 to 1, or just NaCl, 1 to 1. Now here's another image of salt, a much larger image. And again, if we were to do the same process and count all the green, this time the chlorines, we'd see that we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And there actually is 25. I must have missed one. So 25 times 1, 2, 3, 4, 5, 6, 7. 25 times 7 gives us 175 chlorines. And if we were to do the same with the sodiums, we'd see there was 25, giving us 175 sodiums. Again, the ratio that we see here is 1 to 1, or just NaCl. So this is the thing here. Because ionic compounds can form in various sizes, as we just saw, the formula given is a ratio between the two elements. This ratio is called the formula unit. Note, this is different than a covalent compound. So recall, covalent compounds are made by nonmetals. And ionic compounds here are metal and a nonmetal. So the covalent compound is always the same size. So for example, a water molecule is always 2 hydrogens to 1 oxygen. You never could have a water molecule that has 4 oxygens to 2 oxygens. It wouldn't happen. This is the difference between an ionic formula unit and a covalent molecule. So I'm going to end the discussion on that now, and we're going to go back to creating ionic compounds using the crisscross rule. Crisscross rule. So what we're going to do now is we're going to take aluminum and fluorine and we're going to combine these into a formula unit. So how we do this is to follow these easy steps. Step 1. Write the name of the compound by keeping the metal name the same and changing the nonmetal ending to "ide." So that would give us aluminum fluoride. So the "ine" ending changed to IDE. Step 2. Write the symbols along with the charge of the common ion. So again, you can use your periodic table or your common ion chart. So if you were to look up aluminum, the symbol for aluminum is Al, and it has a common ion of 3+. Fluorine has a symbol of F and a common ion of -1. Step 3. Crisscross the charges and write as subscripts. So there's my Al and my Cl. I'm going to take this one negative and crisscross it over to the aluminum. And I'm going to take this 3 and crisscross it to the chlorine. Now notice I don't include the positive or the negative, just the number. Step 4. Combine the symbols and subscripts as a formula unit. 1 is never shown. So our formula unit would be 1 aluminum to 3 chlorines. Let's try that again. Magnesium and oxygen. So step 1, write down the names magnesium. Oxygen changes to oxide. Write down the symbol with the charge. Magnesium has a 2+, oxygen a 2-. Crisscross the numbers, 2 from here, 2 from there. Put it together, Mg2O2. Now, note, for an ionic compound, you use the lowest common ratio. Just like those images we saw of salt, we put the lowest ratio, which is in this case 2 to 2 or just 1 to 1. So what I have here are some practice. So what I'd like you guys to do is to take a minute and pause the video and try to come up with the name of this compound. And then if the name's given, determine the formula. Okay, so give the recording a pause and then we'll meet back here and go through the answers. Okay, hello, welcome back. So, Ba is barium, the oxygen changes to oxide. Next one is sodium bromide. You should have gotten a ratio of 1 to 1, NaBr. Number 3, magnesium iodide, KCl, potassium chloride, strontium fluoride. You should have gotten SrF2, and cesium fluoride would have given you a ratio of 1 to 1, or CSF. Okay, well done. The next thing we're going to tackle in this video is something called polyatomic ions. So first off, let's dissect the words. Polyatomic ions. Poly means many, atomic means atom, and ions mean that charged particle. Put it together and you get many atoms combined together with a charge. These atoms are non-metals for the most part, therefore they are covalently bonded. So examples include carbonate, CO3, -2, sulfate, phosphate. Now, you'll notice those words all ended in -ate. What you'll also notice, the more you work with these polyatomics, is sometimes they end in -ate or -ite. So we'll just run through this quickly. The naming of compounds is systematic. That comes from the IUPAC. This is no different from most of the polyatomic ions. Many polyatomics can be identified from the ending of -ate or -ite. If the polyatomic end with these letters, there is an oxygen in the ion. 8 implies the higher oxidation state, meaning more oxygen, and the -ite implies the lower oxidation state, less oxygen. If there are more than 2 oxidation states, then the following applies. Per-8 means the very highest oxygen state, or hypo-ite means the lowest oxygen state. So examples of -ate and -ite. So these are examples of 4 common states. Note the charge stays the same, only the count on the oxygen changes. So the per 8 would mean the highest oxygen with chlorine. So ClO4, perchlorate. Chlorate, one less oxygen, ClO3. Chlorite, ClO2. And hypochlorite, ClO. Here's another example. Perbromate, BO4. Bromate has the 3 oxygens, ite, 2, and hypobromite, just 1 oxygen. And as it indicated, the charge stays the same. Now below are examples of polyatomics with just 2 common states. So we have nitrate, NO3, and nitrite, NO2. So what do you think sulfate would be and sulfite? If I told you sulfate was SO4, what would sulfite be? If you said SO3, you are correct. Rules for parentheses. Now, parentheses are only used when the following 2 conditions are met. 1, there is a polyatomic ion present, and there are 2 or more of that polyatomic in the formula. So for an example, sodium nitrate, the NO3 is a polyatomic, but there is only 1, so you'll notice there's no brackets. Versus cobalt and nitrate, so NO3 is a polyatomic, and there are now 2 of them. So the parentheses are used with the subscript of 2. So it's saying there's 2 nitrates. NH4, 2 to SO4. NH4 is a polyatomic, and there again are 2 of them. And SO4 is a polyatomic, but there is only 1. Hence no brackets. COOH2, OH is a polyatomic, and there are 2. And Al2CO3, 3. CO3 is a polyatomic, and there are 3 of them. NaOH, OH is the polyatomic, but there's only 1, so no parentheses needed. That is the end of the show, so hopefully that clears up some of the confusion with the ionic compounds, polyatomics, and use of parentheses. Okay, we'll talk to you soon. Thanks for listening.